can only see the top of... No, actually, I see like a blinky thing and your mouth. What's going on?
Well, I'm showing off since I showed off last time the box in which my here. Let me see if I can get a little better angle on this. My robotic arm arrived. I figured I'd show off cool. That we actually completed it. So, got the controller. Excellent. My sons and I spent a few hours building this, and the interesting thing that I found out about this was, it's a really fun project. You were right about that. It's a pretty easy project and worked well for young kids. What I found interesting is that my 10-year-old was less interested in it than my 6-year-old, which was kind of opposite of what I had expected. I kind of expected that the 6-year-old would not have the kind of patience and attention span to, work with it. Right. Turns out, actually worked out really well to have my 6-year-old helping because he has really tiny hands compared to mine, and there are lots and lots of small parts. And it turns out he's very skilled at grabbing the parts. I had taken little, like plastic Tupperware things and separated out the various bags of parts. And he was very good at getting in there, getting the small screws and actually getting them placed properly so that I could screw them in. So I was really impressed. And it was, and then my 10-year-old basically, we kind of got to a point in the project where it was time for the 6-year-old to go to bed. And then the 10-year-old wanted to just kind of read his book for a while. And then as I got closer and closer to being done, the 10-year-old got more and more interested. And so he kind of migrated over to the kitchen table where I was assembling it and helped me with the last few steps. So it was fun. It ended up being
Can you hold that up on camera again?
Oh, sure. Absolutely. So
there we go. So
this is what it looks like. Here, let me pull it back a little bit so it's easier to see. It's got 5 motors. I did learn an important lesson, which is double check your gearboxes every single time, because the very first motor that I assembled turned out to be the one in here that pivots the arm around the base. And I did not have the gearbox assembled properly. One of the pins was not quite aligned, and so this motor was not working at all. So I had to kind of gingerly disassemble as much as I needed to get to the gearbox, rebuild it, and then put it all back together again, which thankfully was manageable without disassembling the entire thing. But working perfectly now. The D-cell batteries, I hope that they last for a while because, those tend to be a little pricier than most. So the next project...
Can that be USB powered, or does it...
Well, it's 4 D-cells, so that would be 6 volts. So USB would only supply 5 volts. So unless you were able to step it up, and I don't know how much current it draws. But the interesting thing, let me see if I can get this loose. The controller actually attaches with standard, I think that's like 0.1 pitch header.
Yep.
Or you can see that. But I'm gonna take a look around and see if I can find that header, maybe attached to a ribbon cable like this, and break out the pins so that I can hook it up to a microcontroller, because that's the next step, is getting this hooked up to a micro and then hopefully connecting it with Kinect, because everything's more awesome with Kinect.
Right.
And now I forget how this thing went together. Great.
I think
brilliant.
You should only do robotic arms with Kinect if there's some danger involved, right? So something like knives or
maybe I'll have to torch or something. Maybe I can ramp up the voltage and see if I can get a little more torque out of the motors.
Yes.
Unfortunately, the gearboxes being what they are, you can only get the thing to move so fast.
Right. And let me apologize for the audio here. I'm actually going through my webcam mic this time because I love WireCast, and I love that it forgets my settings every time, and it gets really confused every single time I launch it, and et cetera, et cetera. And I'm sure none of that is user error. I'm positive of that. But so I've got one of those robotic arms.
Yep.
And the one that I bought didn't have USB connection, but they sold the USB connection as a separate box. They just replaced the board inside with it. But you're right, it's really simple. The motors are they're not servos. They're just inexpensive regular motors with gears attached to them.
Yeah, with the worm drive.
Yeah. Were they all worm drive? I don't recall.
Yeah, the original part on the motor itself is a worm drive, and then it drives several gears to get it, to kind of step down the speed and up the torque.
Right. So they had a program that ran on the desktop that was used to control that. It was actually built in Flash, I believe, and then it turned out they had some little API around it. But it's really very simple. The control itself, just like you said, is really just turn motors on and off. It's not like servos where you want to set it to specific pulse width or anything. It couldn't possibly get easier.
I'll have to see because the manual includes their website. I wonder if it's the same company.
Same company.
Carry on.
Yeah.
The same company that made yours has made mine.
Oh, I'm positive.
If so, then they probably have additional.
I'm positive because this is the USB kit.
Oh, you have it.
Yeah.
Robotic Arm Edge. That's what mine is.
Yeah. So, and you can see screenshots of their little application on the back here.
Right.
And
USB interface. Wow. Yeah. So the USB interface is almost as expensive as the robotic arm itself.
Yeah, I got it through someplace that had it dirt cheap. Quite honestly, I think it would be more fun to do what you're saying, which is a microcontroller approach, because then you can do Bluetooth or your Wi-Fi or whatever,
Right.
Right. So the
Plus,
other fun
it's more of a hacker thing to do.
Yeah. I haven't checked to see if their USB interface requires a driver or if it's like a WinUSB thing. Because if it is a WinUSB thing, you could connect this up to like your Surface and control it from that.
Yeah, it looks like I'm looking at the web page and it looks like it says OS, Windows XP, SP123, Vista, and Windows 7. 64-bit Windows is now supported and can be downloaded here. So
they have a driver.
And it comes with a disk, so my guess is, it's probably has a driver.
Which is weird when stuff like that with just such a simple streaming API. I don't know why people go through the effort of creating custom drivers for those.
Yeah.
Well, but hey,
still, it's cool.
It'll be interesting. I've run into problems with little outfits like that create 64-bit drivers and then don't bother to sign them, and you have to do the whole reboot in that. I forget what that special mode is, but it's the that you sign or let you install unsigned drivers, which is it's deliberately meant to be troublesome because it's the whole idea of protecting people from sort of malicious stuff. But still, it's a pain when these little outfits don't go through that effort. Like just use standard stuff.
The other thing is that if you're, it won't. Okay, so. One of the commenters, Jeff Albrecht, asked if their motors are servos, which we talked about. They're just they're motors. But the URL for the company that makes this is just OWIRobot.com. And you can just search for Robotic Arm Edge, and that'll have the robot. Because I can't post the URL to YouTube for whatever reason. That seems bizarre to me, but I guess that's
have a second
spamming.
One of these.
You do.
I bought two at the time because it was a really good deal from an educational store. And this one's not built, and I was saving it for Ben to build it someday. But let me... So... And again, you can hear everything because I'm going through the webcam here, so again, my apologies. But the motor stuff in it is really, pretty simple stuff.
What I love about the motors is because of the magnets. They're packaged as just, it looks like it's a sheet of motors attached to one another because the magnets make them stick.
And it's a model kit.
Yeah,
there's no glue involved. It's just screws, but it is a model kit.
Yeah, I didn't have an X-Acto knife, but I had my utility knife out, clipping off all the little stubs, because you break off the plastic parts, and then they've got the little plastic stubs that if you don't cut them off, you end up
good set of side cutters.
Yeah, there you go. Yeah, you end up like scraping yourself on them, and you're bleeding all over the kit. That's no fun. So
Jeff
that was my.
Why can't I drop a link in here? That would be YouTube preventing you from doing that. That's standard YouTube policy. You need to make it not a link.
Yeah, so we'll put that. We'll put that link in the. We'll put the link of the other thing in the show notes.
I need to find the place where I bought them from. I put together an article several years ago about this robotic arm, as well as their other one, which was considered their more pro one. But quite honestly, I like this one better.
Right.
They're really very, very fun kits, and just it's a robotic arm, and if you can manage to control it from something, it's just a cool thing.
And actually, I think I remember this link that Jeff sends. There's a link to Louis Benge's website, which is actually using Windows 8.1 with the OWI Robotic Arm.
Okay, there you go.
And I think you may have actually pointed somebody to this because it had something to do with the USB drivers, Windows devices .usb. Maybe it was you, maybe it was somebody else internally, but I remember seeing this page before. So we'll definitely get this in the show notes in addition to the site for the robotic arm. Good fun stuff.
So that's a really cool little arm. Do you recall about how much it cost?
It was right around $60. I got it at Hobby Lobby. My wife's a huge Hobby Lobby fan, so for her birthday, we went and had a Hobby Lobby field trip with the boys. And Hobby Lobby is one of those places where there's really for guys who are into building stuff and models and things like that. There are a few aisles that are sort of more guy-ish, if you will. And so we managed to find one of those, and I thought, I'm going to get one of these because I want to build it. So I think it was a little less than the retail on their website. That is OWI's website, but it was a good deal.
Is this like one of those things where, when you're a little kid and your mother drags you into the most boring clothing store in the world, and you're like, "Can I go to the toy section, please? I won't ask for anything."
Yeah, sort of like that.
And then you come like all the way across the store with something. It's like, I'm not going to get this. I just wanted to show it to you. I'm just going to show it to you.
So I'm not. So I'm definitely not into the sort of the dried floral arrangements or the bedazzling things or there's just all kinds of stuff in there that I can imagine. Actually, one of the things that's cool at a lot of the craft stores is, have you ever seen the computer controlled paper cutters?
Yes, little CNC machines.
That's actually it's like a CNC for paper. Okay,
yes.
That's kind of interesting to me, but what's that?
Or steak.
I said,
you can make steak shapes out of it.
I'm sorry, steak shapes?
Sure, it's got a knife on it. Just slap it down on the top. Yeah, I've lost you. It's okay.
Pete, sometimes you're really weird.
I thought, use a
I like steak, steaks. But
yeah.
Make little swirls out of steak.
You can make little meat cutting shapes
thing
out of it.
How do you clean it once you've cut steak with it, though? That's a little weird. I don't know.
Yeah, that might be gross.
So I had sent you a link, and unfortunately, due to some of our technical difficulties, we're not going to be able to show it. But for folks who are watching live, go check out shirt.woot.com today. They have the best shirt I've seen in probably at least a month or two. If you've ever seen the movie Evil Dead 2, you'll get this right away. I'm not going to describe it beyond that since we can't actually show it, but you got to go check it out if you're watching live. Shirt.woot. Go check it out if you're an Evil Dead fan or a Bruce Campbell fan.
And I am.
I'll just say one word. Groovy.
Shop smart. Shop S-smart. Very nice. Very nice. Hey, so I get a new toy too.
I'm a sucker for Woot. So yesterday, the day before, was tooling around on Woot, and one of the things that they had a monitor sale going, and so in the spirit of your having bought the Seiki, we've never heard of this brand, 4K monitor or 4K TV, I guess. I decided I'm going to replace my Space Heater CCFL backlit monitors, which are probably 5 or 6 years old at this point, with a couple of AOC LED backlit monitors. So hopefully my office can, be actually at like 70 degrees instead of 90 degrees when I close the door.
Nice. Yeah.
So, but they had them. They had them on sale at Woot Refurbs, $99 a piece for their 22-inch widescreen, which isn't nearly as huge as yours, but two of those will do me just fine, and allow me to have kind of one less monitor going.
Yeah, I mean, for displays here, this is the Dell 30, and it's an older one that was their HC series, which is supposed to have like the full color gamut and stuff on it, and it's CCFL backlit or CFL backlit or whatever, and it gets hot. It 30 inches of hot. Interesting. So the Seiki 4K that I have here, the color is not anywhere near as good as what the Dell does with the CFL. It's definitely more of a blue tint when you look at it, but it doesn't get a third as hot. You know, I feel like it's wasting less energy than the smaller screen that's next to it. I just wish the color rendition was better on it. But
well, so have you tried calibrating it at all, or?
Yeah, it's got nothing for calibration.
Oh, okay.
It has color temperature, and that's it. Like, you can't really do much there, and it just doesn't have the full gamut. Like, you know, when you look at it, it gets washed out very quickly, and things get lost in the blacks very quickly, and it's got the sweet spot in the middle, and that's about it. Whereas something like the Dell, I can really experiment with a lot, and I can get the full color range out of that. But it was built specifically for that purpose. And the Dell retail was almost twice as much as the 4K screen. So what are you going to do, right? So I got a toy this week as well. Unfortunately, I left it upstairs, but I do have the keyboard.
You got it. Is that purple? Did you get the purple?
It is purple. Oh, heck yeah.
You see, this is your fault. It's your fault that's out of stock online.
I love the purple color.
I want the purple keyboard. So is that the type cover?
Yeah, so this is the
type cover 2, rather.
Type cover 2.
Very nice.
Ooh, you can even hear it.
It's clicky.
So it is backlit, which I thought was really cool because it just kicked in automatically the other day. What I got was the regular Surface 2. I didn't get the Surface Pro 2. And you can tell I had the Surface 2 upstairs without the keyboard attached to it because sometimes I just don't like lugging the keyboard around if I'm not going to use it. There is some weight to this. But so I have a regular old Surface as well, which is good, but I've always been annoyed at the speed on it, or I should say the lack of speed on it.
The RT or the Pro?
Surface RT. Right.
Okay.
So
yeah, because
the old Surface RT. When I would hit web pages and stuff and everything, if you're used to a high-powered desktop, it was sometimes kind of painful because it would take a long time to load. All the apps and all the stuff in the modern side that were optimized for it were fine, but when I got to a web page, it was just not. Like, Facebook is the worst web page you could ever load on a low-powered device. But there's an app for that anyway, right? So the new one, I was trying that out, and I couldn't believe how much snappier that was.
Yeah,
so I wasn't.
It is.
My expectations for the perf increase were not huge because it's still ARM, it's still everything, but it's probably anecdotal. It feels twice as fast. Like, I don't know what the actual numbers are, but it feels at least twice as fast.
Yeah, I mean, I was checking them out. I went to the Tyson's Corner store earlier this week, just to see what kind of new stuff was in, and the Surface 2 is. I mean, it's a night and day difference in terms of performance. I mean, the 8.1 upgrade definitely improved things on the RT, but Surface 2 is a lot faster. So you didn't order a Pro 2?
So the Pro is one of those interesting devices. I've got a Pro 1, and I find that I almost never use it. And the reason is it's kind of big for a tablet and kind of small for a laptop for the way I would use these things. So I lug the W520 around with me whenever I travel, and I wish this had a touch screen because it's got 16 gigs of RAM, 4 cores, big SSD, all that kind of stuff. Heavy as anything. The power supply for it weighs as much as my Surface. But it's got a good sized screen on it, and it's good for presenting and everything like that. The Surface Pro, I've used it a bunch before, and I really do like it. But it's not quite up to speed for something like a desktop replacement like the W520 is. And it's just a little thick and heavy for me to use as a companion device. Like, it doesn't feel right to have a laptop and that. And so just sort of the mode I've settled on is a laptop or an Ultrabook. I'll probably end up getting some new Ultrabook here when we do our next refresh, and then an
Right.
RT device, just because I like the weight and the form factor and the thickness and stuff on the RT device.
Yeah, I'm torn between. I'm fairly certain that I'm going to get either a Pro or a Pro 2. I'm looking actually to replace my wife's current machine. She's using one of the Samsung slates, one of those that like the ones we gave away at Build. And eventually I want to make sure she's just covered, for the long term.
That's a prototype, non-retail.
Yeah, exactly.
Device, right? Yeah, so not usually the most trouble-free device to give to like your wife, right?
Right. It's not highly optimized, we'll put it that way. But she really loves it in terms of being able to carry it around. And I'd be pretty sure that even the older Surface Pro would be an easy replacement for that form factor, because they're just about the same size. The Pro is probably a little lighter. And the only question would be how she would do with, I would probably get her a type cover instead of, the little Bluetooth keyboard that came with that. But I think she'd be very happy with the Surface Pro.
The type cover 2 is really good. So what I liked about it is I was able to type on the couch the other day with it, because it's stiffer than the original type cover. And the other thing that we did is it has the same, what's that, like Gore-Tex or something, that coating that's on it that's more of a fabric. It's got that same coating on it that the touch cover has, as opposed to the old type cover, which had sort of a plastic feel to it.
Right.
So I happen to like that a bit more. So
cool.
The other thing that I was speaking to DJs and performers and stuff at the Decibel conference back in September, and those folks got to use Tractor and a bunch of other apps running on the Surface Pro, because we didn't have the Pro 2 or anything like that at the time. And they really liked that because it was powerful enough for them to bring with them to run all these apps, but it was small enough that they can just throw it in their gig bag and be fine for traveling with it. So that definitely hits that sweet spot for people. Whereas even like a larger laptop is large enough that it's amazing to me how much these performers pay attention to what will or will not fit in a gig bag. Like everything has to be, if it won't fit in a backpack with everything else, it's just not worth bringing.
Yeah. So, well, the other thing, I mean, from my perspective, one thing that I'm lacking right now, I love the Lenovo Carbon X1 Touch that I use regularly, but it doesn't have a digitizer. And, so for drawing or handwriting or things like that, I'd really like to have a device that has a digitizer. But all of that is not related to the topic at hand, and as was observed on the GHI forums, we have a tendency to be somewhat wordy. We can spend a half an hour on our T-shirts.
Oh, hey, here's my T-shirt today.
Speaking of, there you go. What do we got? Okay, I get the Abbey Road reference. I'm not recognizing the characters.
Miyazaki stuff.
Okay. Very nice. Very nice.
Yes, so thank you for bringing us back up around, because I would talk for another 20 minutes about Surface and some things I like about it and stuff. So this is not a product placement. What we are going to talk about today is building your own PCBs. Right?
So what's a PCB?
Why, this is a PCB, Andrew. Let me see here. Ooh, it's got the blue light coming off the... Come on, focus! There we go. All right. So that's a PCB. And we're done.
You mean like this?
Mine's bigger.
Is that gonna... Oh.
Yours is pretty, but you have purple.
Mine's cuter. I have purple.
There you go.
In focus.
Yes. This is a good
PCB
opportunity for us to practice like
printed circuit board.
Really yes. So printed circuit board. So what we want to talk about today is how to go about designing one and building one yourself. And WireCast, of course, has conspired against me, so I'm not going to do any live demos of this stuff. But I'll probably end up either pointing to some videos, on YouTube. So lots of great tutorials on this in the show notes, and or recording a little something quick myself. So you've designed a few PCBs.
I have.
Right.
Yes, indeed.
Can you explain what the one that was just in your hand does?
So I'll put it back up just so folks can see. So this is actually a very, very simple PCB. This is something back when I was trying to figure out how to control an infrared remote control helicopter. I initially started off with some single IR LED solutions that just really weren't cutting it. And what I noticed when I took apart one of the controllers for these IR helicopters is that they used an array of 3 IR LEDs for the controls. And so I thought, well, let me do this. I'm going to go ahead and create first I did a breadboard version, and I don't think I actually, hold on.
So what you did is there was something that was not necessarily commercially available that you wanted to create yourself.
Correct.
To work with something else that you had.
Yeah. So initially I created a breadboard version, which I've since taken apart, but goodness. Hold on. There it is.
So for folks that aren't familiar with it, a breadboard is a way to prototype circuits. You plug components into it, use wires to connect the pieces together. And it's a good way to debug stuff and kind of figure out what's working and what's not working in the circuit before you go and have something printed up.
Right. And then after having breadboarded the circuit and made sure it worked, I did a perf board prototype. So basically the LEDs that you see there at the top are actually, oops, I think I have that upside down.
That around? Show us the back.
Okay. So on the perf board, I've got some wires that are connecting all the circuits, and my really good soldering. You can tell my soldering skills hopefully have improved since I did this version. But basically, this allowed me to test this as a Gadgeteer module since I had the socket for Gadgeteer, and then I also have a pin header that allowed me to connect it, with just jumper wires. But basically, this allowed me to kind of figure out, okay, how will this work? And I had a whole lot of help on designing all of this from some of the community members on the GHI forums. And then what I ended up with, you can see this. This is actually the green version. This was, let's see if we can get that to focus. Come on, focus.
Hold it in front of your mic here for a second, because I think it's focusing. All right, stop there. There you go.
All right. So this has 3 narrow beam IR LEDs. Actually, I've got another one here, so I don't have to hold up the whole rig.
Not counting whatever just fell off.
No, that was actually, this was one of my other prototypes. This one has there we go. This one has a wide and or a two wide beam and 2 anyway. There we go. So this has 2 different IR LED types in terms of the beam width. I ended up just going with the same for the subsequent ones. But the way that I designed the PCB, it's got pads both on the back and the front, and it's designed such that you can orient the IR LEDs in any of 3 configurations. So you can have the IR LEDs at the top, on the back, or edge mount. So that depending on how you want to mount the board in your project, you've got some flexibility there. So basically, once having prototyped and then done the perf board prototype and verified that the circuit actually worked, that's when I went in and started using some of the PCB software. In my case, I used a piece of software called KiCad, which actually has a free version that's pretty functional for simple boards. So like my board is just a simple 2-layer board. There's no, multiple layers. There's very few. Actually, I don't think I have any. There. Yeah,
so
sorry.
Layers here, for folks that aren't familiar with it, is referring to the copper on the top and the copper on the bottom in this case. So that's 2 layers. If there are other intermediate layers of copper, then that's 3 layer, 4. It's usually like 4 layers, 6 layer, 8 layers, stuff like that. And things like motherboards and computers have 12 layers, 20 plus layers, etc. And the reason that's done is it gives you more places where you can route signals without worrying about crossing wires, basically.
Right. And that starts to get very expensive. I mean, for hobbyist PCB making, probably 4 layers, the most you're going to really do, because, otherwise it starts to get both very complicated in terms of the design and, most of the time if you're designing something that has more layers, you're going to have to use software that actually costs money. The free stuff generally doesn't do, the multi-layer kind of designs.
All right, so let's back up a little bit here.
Okay.
All right, so let me show just some of the boards I've designed here for a second. Not all this stuff, but I'm into synthesizer stuff, right? So I've designed some boards here that are specifically breakouts for the types of connections I would normally use. So like this DIN connection here. Let me move that out of the way. Let's see.
So these ones are new to me. I hadn't seen these.
Yeah, I haven't done anything productive with these yet. That's why. This one is a breakout of TRS sockets, right? So that I can just connect them up to anything. And then let me go all the way over here. This one right here. Here we go. That's the board that I showed a little bit earlier. That's got an ARM processor on it, a bunch of helper things, and its whole purpose, if I get around to it here at some point, is to interface with something like Gadgeteer to be able to control synthesizers by, it's the idea is that it supports MIDI input and output, as well as analog output for like clock signals and CV and gate and stuff like that, and then also DIN sync, which is something that the old Roland things use. So this is something that didn't exist in this form, and it's something that I wanted to create for my own use. So I went and designed a circuit for it, designed a PCB for it, etc., just like you did on yours. The same thing. These other breakouts here, dead simple PCBs, but I get irritated with having to constantly go in a breadboard and swap 600 wires just for the same type of stuff all the time. So having something socketed here that I can mess with really helps out a bunch.
Yeah, exactly. And now, earlier you had actually created a MIDI module, like a MIDI in, MIDI out for Gadgeteer, and that's something that I used in putting together. I had done a Gadgeteer project I called the Me Blippiator, which was just sort of a simple step sequencer for a Me Blip micro synthesizer, like not handmade, but a kit synthesizer that I was able to get that was really inexpensive and just a fun little synthesizer project.
Yep. I'm actually hoping to have him on the show here at some point, because he did some
that would be awesome
DIY projects. Yeah.
Yeah, and so that's one that I know you had up for sale. I've also sold probably maybe a dozen of my IR modules, and it's this is not something that either of us are likely to make. We're not going to quit our day jobs and start making little PCBs here or there, but it's kind of neat to know that to be able to create something like that and then have it be something that somebody's interested enough that, hey, can I buy one of those? Plus when I can point to the checking account and say to my wife, hey, look at how many of these I've sold. That gives me a nice little way of justifying, the investments in additional tools and parts.
Right. So I sold out of pretty much all of these, and I made a couple of runs of it, and actually, some people in the UK bought these for education. All right, so
Oops,
I'm not going to sell
God
that
for that.
So people in the UK bought these for education in schools, which is cool. So I did really well on that one. I designed another PCB, which sold exactly one, because nobody else was interested in it. And this was my Nintendo controller breakout. So let me
Oh, yeah. You sent me one of those.
Yeah, and you didn't even use it. Even for free, you didn't use it. So nobody was interested in the Nintendo controller.
I'll get around to it, I promise.
Yes. And actually, you can buy new Nintendo controllers, so no worries there. Like, not everything's going to be a hit, of course, but it was still fun to design this and put it together and write the software and everything for it. But, so what I want to do here, though, is talk about, the process from top to bottom, right? So if you're looking to create a custom PCB, or the birch board, yes, the thing. So if you're looking to create a custom PCB, there are several steps that you need to do, right? The first one is to what's called capture the schematic. Well, you're going to come up with an
Mm-hmm.
idea and all that stuff, right? So then you're going to
Right.
capture the schematic. When I was first starting out doing this, it's a step that I had skipped because I didn't realize how useful it was. I just went right to routing a PCB like I did on my original my MIDI I/O board that's over here behind here that's routing MIDI to all those different devices. Because I didn't realize that by capturing the schematic, which is where you're dealing with the symbols for all the different electrical components, and that you're routing the signals between them and everything there, what that enables you to do is verify your PCB design later on against that particular schematic. So that's the first part. And you're going
Mm-hmm.
to do that in a piece of software. Then you're probably going to have to build out a couple of parts that aren't in the library for the tool that you use. So, for example, they might not have every last processor that you're interested in, or the specific brand and shape of IC that you're using for, say, like a gate or something like that. So you
Right.
might have to create a few of those. And how you do that in each piece of software is going to be quite different. So then from that, you're going to create the PCB layout. And the PCB layout is usually done in either the same piece of software or a related piece of software. And what it does is it pulls in the design that you created in the schematic, and then it just throws everything onto a design surface for you to be able to position the components, and then actually turn the logical connections between those components into physical traces on the PCB. And traces are essentially, think of them like wires. They're the bits of copper that are left on the PCB to route signals from one component to another. Once that's done, you're going to verify it and do some testing on it, to make sure that your traces, these connections between these things, are meet minimum requirements for the space between them, as well as the thickness of them, and that varies
Mm-hmm.
slightly from company to company that does that stuff.
Right.
You're going to then export these files, and this is where it suddenly gets like all 80s on you, right? You export these Gerber files, and these Gerber
Right.
files are essentially just renderings of each layer. So there's a a Gerber file that is the top layers traces, right? And then there'll be a Gerber file which is the solder mask that goes over everything except for the individual pads that are on there. And then there's
Right.
another Gerber file which is just the like the silk screen that has all the text on it, and then you repeat that for each layer that you have. So the same thing on the bottom. And then there's also a
Right.
drill file which tells them where to drill all the different holes in the PCB. So if you're
Right.
if you're looking at
Yeah,
something
it
like
gets very
this,
complicated very quickly.
so luckily you can't really see traces and stuff. Black is not a good color for showing those traces and everything, but let's see. Does this
You can I think you can kind of see them on mine.
purple
It's the
maybe actually
purple.
be a better. Let's see. Yeah, if you get too close, it just doesn't want to focus that close.
There it
Oh, there
goes.
we go. There you.
Yeah, you can kind of
Perfect.
see the traces there. My traces are very, very simple. One of the things that changed from my board with some of the community review was, there's a pretty strong bias against right angles in your traces. So you can see where my traces make turns, they use 45s to kind of round the corners, if you will.
And the funny thing about that is it's really not based much in electrical theory as much as it is just based on problems with etching, because the process that they go through to etch stuff here can sometimes have issues with sharp corners where it's going to like etch away too much or not etch away enough or something like that.
I always thought it was because the electrons get blocked, get into a traffic jam when they try to turn the corner. If th're going too fast, they all kind of slam into one another.
The wall. Yeah. All right. So those are the high level steps.
Right.
The last step is you're going to send it to a fabricator, and we'll talk about a couple of those fabricators here in a second. So the software that you used is called Eagle, right? So
Yes.
it's an acronym or something, because it's all capital Eagle. And then I use a piece of software called DipTrace,
Mm-hmm.
DIPTRACE. Now, I'm going to give you my opinion on the two of these for a second, and then you can tell me how full of crap I am.
Okay.
So Eagle is by far the standard for hobbyists, right? I think
Mm-hmm.
it's fair to say. It does get pretty expensive the minute you move up beyond 5 centimeter by 5 centimeter. So anything larger than like a business card or something gets pretty expensive very quickly.
Right.
My biggest issue with Eagle, and I did use it for quite a while, was it was written by somebody who has obviously never used a computer at any other time in their life, because the user interface on it is so backwards from every other piece of software that you might use that I just found myself frustrated constantly. Like you'd have to do stupid things like copying and pasting in it is one of the world's hardest tasks. Like you have to
Right.
click the tool to copy and then you select the thing that you're going to copy. Who does that?
Right.
That's the most ridiculous. And there are tons of things like that that just started making me pull my hair out, because unless you live in that, and that's the only thing you ever do in a computer, it gets frustrating pretty quickly, at least to me. What's your opinion on it?
Well, so yeah, I definitely did not find it to be the world's most intuitive software.
By far.
Part of, yeah. So, I mean, there are certainly times when I kind of felt like I needed to pull my hair out a little bit, figuring out how to do something because it just wasn't doing what I expected it to do. In some ways, well, so I guess part of what was helpful is I started with, because Gadgeteer is an open standard, both software and hardware, all of the files for the hardware files for the Gadgeteer modules are actually available as Eagle files. And so I was able to import the Eagle file or just open up the Eagle file for an existing module and started my design with that. Basically kind of ripped all the components and traces off of an existing board, because part of what that gave me is the layout of these modules is specific in terms of the size of the holes and the distance between them. And so starting with an existing module made it easier for me. Plus, then it also already had the 10-pin socket layout done. So all I needed to do is kind of move that around to where I wanted it. The bad news was that I started with that, but my board wasn't going to be the same size. So in the process of resizing and such, I had lines that weren't connected. And so thanks to Valentin, one of the GHI forum members, who may actually be watching live if he set himself a reminder. Thanks to Valentin helping review some of my Eagle files, he helped me kind of clean up the design so that things would actually manufacture properly. And that's one of the things that's a little tricky, and I don't know if it's true with DipTrace or if it's just true with Eagle, is if you don't know what you're doing, there are things that you can either omit or, if you have things on the wrong layer, the things aren't going to work. Things won't export to the Gerbers properly if you don't have, things on the right layer in the software, if that makes sense.
So I found that DipTrace was better in those cases in that it just did a better job of showing you what's going to be exported and what things are on particular layers. And, and for me, and all these programs are roughly the same in this regard, but I found that slightly easier. And there were other things such that DipTrace would let me easily pull in a bitmap and use non-vector fonts, which is something that Eagle has significant issues with both of those. Like pulling in a bitmap to decorate the board, to do, simple things, or vector artwork anyway, like my little, let me see, focus. Boy. I need to just set up a separate camera that's just for like showing stuff up.
Well, you've got you have the document camera,
use
right?
that as a source. Yeah, I've got a document
Yeah,
camera.
we'll have to try that next time.
Because, even then I could stick that on the laptop as a way to do the screens as opposed to, it's hacky, but that might work.
Yeah.
So I do want to do one thing here for a second, and I want to show some screenshots, which is going to result in the audio getting a little clicky for a second. But I feel like if I don't show what the software looks like, folks are going to really be missing out on the context of it. So let me switch over here for a second and then add the audio to it. I'm doing this on the fly, so good luck with that.
We live for danger. Danger is our middle name.
And hopefully everybody can hear me now. Okay. So you should be able to see this this shot on here. I'm showing the schematic designer in DipTrace, and this is showing a processor that I was working on. This is actually part of that board that you saw earlier, where there's my wonderful like rerouted to be a mess that things. Here's like the MIDI part of the interface. All right. Here is some stuff for the sequencer clock, and it lets me. So DipTrace lets me have these hierarchical schematics, which, as I recall, isn't available on the free version or even the low cost A schematic, or excuse me, into a PCB layout. So the PCB layout that we're looking at here is the one from that the TRS times 4, so that the 4 audio outputs. And you can see I've got the routing on here and a bunch of other stuff. And because this is a new PC I have here, and I realized I didn't install the font that I was using on that, so the font didn't come quite through. But you can see here, like, here are the individual traces. It shows me if I highlight them. Like this one here, it tells me things like what net it's on, other stuff. So there is a bit of a learning curve to oh, actually, and interesting. Did that actually go through? Let me resume this again. How funny. Well, not funny at all. Sorry, here is the PCB layout. And here you go.
Yeah, I'm still seeing the...
Yeah, well, you're... Yeah.
I know, I'm a little behind, but...
See, that's what happens. All right, I noticed that the audio was fine. I was like, oh, obviously I wasn't doing something right. Sorry. All right, so that's the PCB layout piece. Again, for the TRS times 4.
Now you mentioned routing, right? So yes. Routing is, for something simple like the Nintendo controller or my IR module, routing's not a really big deal. You could actually do that manually, and it doesn't take any sweat. But when you start getting into something like where you've got one of these ARM processors, you've got a lot of pins that you're connecting to. And depending on the size of the board in particular, you might need to have some vias. You might need to, and one of the things that's been discussed a number of times in the GHI forums is the kind of merits and demerits of various PCB software from the standpoint of the quality of their auto router. Right. Because trying to lay out, as you start getting into more and more and more complex circuits, trying to lay those routes out by hand gets to be a real pain in the behind if that's what you have to do. Whereas if the software has a good auto router, you can usually end up with something that's pretty close to what you need, and then tweak by hand anything that needs tweaking.
You can't. So I tend not to use the auto router stuff. Let me resume this share again here.
Okay.
Switch back over. So this is a Flickr image of a simple 4-port MIDI interface that I built, and you can see that the routing is more complex than what I have with some of the other things. There is an ARM processor there, lots of vias and stuff. It's still only a 2-layer board, which does restrict where you can go routing wise, because you only have the 2 layers to mess with.
Right.
But I routed this by hand, and it does take some work to do that. When I auto route stuff, I'm just never happy with the results. I'm just never happy with what comes out of there.
Maybe that's because you have the wrong auto router.
I've tried it in a couple of pieces of software, and honestly, let me get back over here. Unless you've bought one of the $20,000 pieces of software, the auto routers are usually fairly crap. I mean, it's one of those things where that's where the real value is.
Right.
Because if you're creating a motherboard for a PC, you don't really want to manually route all of that. I mean, they have like BGAs and stuff in it where they have to route through multiple different layers, and you don't want to do that manually. What you want to do is, like you said, start with the auto routing piece, or maybe individual sections that are auto routed, and then sort of glue it all together yourself afterwards. Right. So you go through the process here. You create the PCB, you export that. Now the the biggest thing that used to be the blocker for most folks for doing this sort of hobby in the past was, what do you do with it at that point? So you used to see lots of home etching kits, which is awesome if you have some place where you could dispose of the chemicals without getting arrested, and you don't have little children snooping around, because it's like, what's it, like hydrochloric acid and a bunch of other stuff that you use to through. And then it's got the
it's just a
metals
nasty
dissolved
product
in it. Yeah.
Right. Well, and then the other thing about it is that the way that you have to basically create a mask first, which typically you do with like an inkjet printer or some kind of printer, and then you have to expose it in a certain way, and then you have to etch it. There's a lot of steps.
It's lined up on both sides.
Right.
It's
a very fiddly. Yeah, it's a very fiddly process. The other thing that you can do if you've got a CNC machine is you can actually use a CNC machine, and there are boards that that have the copper, and you can just mill the copper away to form the circuits. I saw actually they have a great one of these on campus at the lab for Microsoft Research. Right, that's that's a lab I really want to have, because they have all of the awesome. They have laser cutters and milling machines and all kinds of good stuff. But most of us can't really afford the scratch for a CNC milling machine just for PCBs. It's not that's a terribly.
Good thing. It creates lots of really fine dust, both copper and a little bit of the substrate and stuff in there too, which can be a problem. It's not a kitchen table thing for sure. But once you do that, it can be, unless you're really good at this, it can be hard to solder on that because you don't have a solder mask unless you go and buy a solder mask kit. And those are expensive and messy and require another laminating machine and all that kind of stuff. So now, to be clear, people do this, and they do this really well. But you essentially have to have a manufacturing center inside your house for this, right?
Well, and both of those techniques, the etching technique and the CNC technique, are not well suited to running large quantities or even medium quantities of boards. Those are they're really techniques that are primarily for one-offs, and like I need a prototype and I need it right now. Yeah. Right. If you're in a scenario where you want to build a circuit and you need to have that circuit done in an hour, then a CNC machine is probably the only thing that's going to do the job for you. But do you want to start on the next? Yeah. So the other way to do it.
Yeah. So the other way to do this is to send it out, and there are actually a lot of places now that cater towards hobbyists, which was not the case even like 5 years ago, where it used to be that if you wanted to get a PCB done, you were looking at multiple hundreds of dollars to get something put together. So I didn't know about some of the hobbyist shops, and I used a prototyping service for my first board that I did several years ago for my MIDI board, and I think that ended up running me about $100 for that board, right?
And that's using their that for one, slower. Or was that for?
Go ahead.
Was that for one or for many?
That was for one, right?
Wow.
So at the time, and because people are like, wow, why would you ever do this when you can buy the whole device from a third party for like $150? And I was like, well, I wanted one myself. But I have since learned, and the board was, about this big. So it's larger than some places will do anyway. But I've since also learned how I could make it much smaller.
Right.
So that was expensive. It was done by a place in Germany who still advertises in all the magazines. It's like PCB Pool or something like that. They did a great job. They sent me photos from each and every step along the way and everything. But still, it was like $100 for that one board. And that was green. That wasn't even any special screens. Then I started using Seed Studio, SEEED Studio. And that's they're in, I think, China, I believe, right?
Yeah.
And they cater towards hobbyists. And that was a pretty good service. Shipping from China is... always pay the extra for DHL. Let me put it that way. Like, just factor that into your cost, because China Post is the slowest way to get anything from anywhere. It goes to
be absolutely sure when you place your order that you leave that if you need something now, don't order it around the Chinese New Year, because everything shuts down for over a week. I mean, it's
Yeah.
crazy.
Yeah. It
So,
was absolutely
yeah.
insane. So I used them for a while, and they still do well. But they charged a ridiculous amount for like black silkscreen and stuff at the time, or colored silkscreen. So then I started working with a company called DF Robot. DF Robot I knew because they cater towards the robot hobby, and they have lots of DIY stuff and everything, and I've purchased things from them before. They started offering a PCB service. Now, the reason that these companies can offer these PCB services is they batch the PCBs together. Like when an actual PCB is manufactured from someplace, it's on a sheet that's like, well, you can't really see. It's pretty sizable. It's the size of my screen here. And there are some cool videos on YouTube that I'll link to that show how that process goes through. And they'll batch them together to use as much of the PC as possible. DF Robot does really well in that, despite that batching process, you're still only looking at a few days for them to take care of that on their side.
Right.
The thing I like the most about what they do is they don't charge much extra for black silkscreen. Their prices start at $1 a board for a quantity of 10. So you're looking at, if you want a green PCB that's 5 centimeters by 5 centimeters, order it in a batch of 10. They cost like $10, which is $10 for 10 boards is pretty amazing. Pretty amazing. Now the price goes down if you order larger quantities. They're also very flexible in that. So this board right here is rectangular. So it fits I believe this is the 10 centimeter layout, right? It fits the 10 centimeter by 10 centimeter square that most companies will fit in, but it wastes half the space because you're charged by that square, and like each square is larger. So what they let you do is put 2 of them in that space, and they charge you a nominal fee for the second one that's in there, right? So they do a really good job with that. And the other thing that I like about them as a hobby service, they recognize that you're not an expert at this. And so if you do something kind of dumb, like for example, I sent something over to them and the solder mask was covering all the pads on one of the ARM processors that I had on there. So there's no way I would have been able to ever solder anything to it, right?
Yeah, short of scraping the solder mask off.
Yeah, which that's
which would be no fun.
Yeah, the stuff's like cured on, and yeah. So they sent it back and they're like, hey, this isn't going to work. You sure that's what you meant to do? And I was like, oh, thanks. And I was able to fix it. And it was an error that when I had designed my own a package for that inside the tool, I forgot to have the keep out area for the solder mask, right?
Right.
So again, really great stuff there. And that process is really simple. You go to their website, you place the order, and then you zip up all your exported files and you email it to them with the order number, and then they get back to you and say, okay, thank you. If there are any problems, they'll let you know about the problems. Otherwise, a package shows up in roughly a week to a week and a half, right?
Right.
So not as immediate as milling it yourself, but a week to a week and a half is pretty good.
Right.
I think
and
longest
a lot
I've had. Oh, go ahead.
And a lot less hassle. Less messy. And every bit as satisfying.
It is. There is something to be said for getting this in the mail and knowing that you designed it and it's a physical thing, and it's like it's something you can hold in your hand, and it's something that you designed that has come into the physical world. I mean, I've talked about this before, where I think part of the reason I like making stuff is software is really cool, but it usually doesn't come out of the computer, right? There's no physical manifestation of that. Usually, I think Weird Science is about the only time I've ever seen a physical manifestation of software. But when you have something designed like this and you can then hold it in your hand afterwards, that's a pretty big deal to me.
Yeah. Well,
so you've also
actually
used another company.
Yeah. So, but on the topic of, sort of that magic of making physical things, it reminds me of, when I was back in my theater days, I did all kinds of different things. I did carpentry, but one of the things that I did that really felt like magic was welding, where you would take 2 pieces of metal and when you're done, they're 1 piece of metal. It's not like carpentry where you've got fasteners and glue and all that kind of stuff. And this feels in some ways kind of a very similar thing, that you're creating something tangible and really cool. So I've used a couple of different services. I used initially I used an outfit called Batch PCB, which I think was actually a service that, I don't know if it was somebody at SparkFun or if it was kind of a spinoff from SparkFun. But basically, it was the same idea. They would batch up different people's orders, and once they had enough for a board, they would send it out. And you could actually submit your Gerbers and such online, which was very convenient. And they had, status. You could look up status information to see where things were in the process. Unfortunately, Batch PCB is no longer. They've actually closed their doors. So they actually have kind of moved all of their customers over to a service called OSH Park, is oshpark.com. And that is actually used to be called Dorkbot PDX, which was run by a guy named Neil, who went by the online handle Lan, or Lane. I don't know how he pronounces it.
I can't imagine why you would move away from a URL like Dorkbot.
Dorkbot. Well, the cool thing is that OSH Park, which I actually haven't ordered since they changed names, but they do a really good job. They actually manufacture their boards here in the U.S., which means less potentially bad things to happen in shipping, which is a good thing.
And also, to be clear, so the environmental regulations and stuff over here are much stricter than what you have in China. So, you
Right.
are, if you can use the services in the U.S. and you're willing to pay for that, you're doing like much better by, I think, everybody in the process.
Well, and the honestly, the labor conditions in China kind of give me pause sometimes too, and it's one of those things where it's difficult to avoid with electronics, but that is another thing that's a consideration.
Yep.
So their boards run about $5 per square inch for 3 copies. So basically, they require a minimum of 3 boards per design, and then it's $5 per square inch. So, my board, I don't remember exactly how much it cost, but it was really cheap compared to, what it would have cost me to do a one-off somewhere. One thing, this is a batch PCB version, and I'm going to see if I can get in here and get focused so you can kind of see. Let's see if I can hold this steady and get focused in.
It's like we need to have a little set of helpers.
So if you look, it's pretty stable right now. There's a resistor just above the socket, and yep. I've actually soldered a little jumper wire, because one of the things that you don't get with hobbyist grade boards is you don't get the level of quality control that you get on professional PCBs. So in this case, I had a trace that was bad, and so I basically had to solder a jumper wire from one side of the resistor onto the pin where it was supposed to be going. So this is a board, for example, that I would never sell, but with a little jumper wire, it works just fine. But that is something you just need to bear in mind when you're paying kind of the inexpensive hobbyist grade boards. Most really high-end professional PCB manufacturers will also include in the price a certain amount of both pre-testing of designs, as you mentioned. Look out for that, Pete. As well as they'll do electronic testing, and you can actually pay extra for some of the services where they'll test electronically 100% of the boards, so that all of your traces get tested for continuity, or they can just do a percentage of the boards. Yes,
I'm so rudely rattling around here. My God.
Yeah, what's up with that?
I was trying to find. I have a couple of PCBs here on my disaster of a desk that you could pay for 100% electrical test from places like
Right.
CF Robot. So I think it ends up costing just a little bit more. And they went through, and any boards that didn't meet the required specifications, they put like a red X across.
Mm-hmm.
And the funny thing is, for anybody who saw last week, they saw that I had the pink GHI Gamo on there that I took apart. Well, I hadn't yet put it back together, and now it is scattered across the floor. Yeah, so that's going to be difficult. And of course, I can't find the PCB that I'm looking for. But anyway, but they had several. I actually had 100 of one of these boards printed up, and there are about 5 of them that didn't pass QC, and they put red X's through.
did they still charge you for those, or?
So it's just like professional PCB stuff where
Uh-huh.
you get charged for everything that comes off the assembly line,
Right.
everything that comes off the fab. But
Mm-hmm.
you have to figure there's going to be a certain amount of defective stuff in there. And really,
Right.
the same thing happens with production boards. And the more complex the board, the more defects you typically have. So when people are
Right.
doing like these motherboards with super small traces and 12 layers on it, the part of the price of that you as a consumer pay, it has to
Right.
account for the boards that just didn't make it through and didn't meet the right quality level.
So if you're manufacturing something, you should probably figure a percentage of bad boards into your calculations when you're ordering.
Absolutely. And that percentage is going to depend upon, again, the complexity of the board and who's printing it and stuff like that.
Right.
So it's one of those things that if you're not expecting that up front, you're going to feel cheated. But you just have to understand that's just part of the process. You're not being ripped off. That's just the way this particular type of manufacturing happens. And honestly, it's the way each and every type of thing else.
Yeah, and I think anybody who's had a house built probably understands this kind of idea as well.
Yeah.
So. Actually, it actually reminds me of we had the windows replaced in our house last winter, and I guess in January or so, and sure enough, we had, I think, 30 windows replaced, and one of them, which happened to be in our bedroom, had a manufacturing defect in the frame, and it wasn't anything that would, it didn't actually leak air or anything. But when we sent the picture to the company, they said, "Yeah, we'll just we'll build a new one." They actually make them in Maryland, and so we'll build a new one and replace it. And they sent somebody over with a new window, and a couple hours they were done.
To bring us around to where we started, and because my Surface 2 is upstairs, speaking of like defect stuff. So this is a piece of, I think it's plastic on the back of Surface, right? And then the Surface 2 has roughly the same thing.
Right, that's where the radios go, right?
Well, it's the piece of plastic here that I think it just covers the webcam, and I'm not sure what else is in there. But yeah, probably
I think it covers the antennas. Yeah,
most likely
because magnesium would be a little harder to get the signal through.
So these are custom trimmed on the assembly line because the cases themselves, being something that's molded through whatever process that we do there, is going to have very slight variances in where this top is. Like some might come out slightly larger or slightly smaller due to shrinkage. So what they do is that these pieces are custom cut to fit the rest of the case. That way you don't have any kind of like issues with the bumps and
bumper
stuff here,
ridge, right?
So it's the same thing, and part of what you pay for in different types of manufacturing is what that kind of what they do in the cases when things are defective. Either stuff gets tossed away, things are custom cut, or in the cases of the cheapest things that you buy, it's just put together like that anyway, and you just use it as is, right?
Yeah, exactly.
So to kind of sum up what we were doing here, because I know we're just a little bit over, I'll put in the show notes here the links to some of these particular products that you use. Neither Andrew nor I have a ton of electronics experience. We've just been kind of learning as we go along here. Creating these things is not hard. And when you're looking at an outlay of $10 for a few boards, that's like you can experiment for that amount of money, right? I mean, you can do a couple of rounds and have some failures there and still feel like, hey, I didn't spend much more than a couple of Starbucks drinks or something for the week. So it's really
and some time.
I think it's affordable. Yeah, and the time is the fun part. So come up with an idea. Capture the schematic in one of these pieces of software. And there are a couple other pieces of software I didn't mention, like DreamSpark and KiCad and some other ones that people really like as well. And I'll try to include those in the links. My own personal recommendation, again, is DipTrace. And I know also Eagle, again, has lots of industry support as well. Then you're going to create your PCB layout, export those files, and send them over to a place like DF Robot or I was going to say Dorkbox or open source hardware.
OSH Park.
OSH
I guess
Park.
OSH Park.
And the other thing is understand that the communities around these things can be very, very
Yeah.
helpful. So in the case for both me and Andrew, since we were developing boards that were for use for Gadgeteer and also for like Netuino and stuff, those communities were very helpful because there are
Yeah.
people who have gone further than we have. Who are able to, say, hey, you might want to think about rerouting this piece because of interference, or you want these to be the same length or anything like that.
Right.
Super, super helpful. You don't have to figure all this stuff out on your own.
Yeah, and an example of that, I mean, one of the things that I really like about GHI as a company is that everybody from GHI who has the expertise, including Gus, the owner, are on the forums all the time. And one of the last pieces of advice I got for my board was I was missing a really important piece from my circuit. Namely, I did not have a resistor between the CPU pin that was switching on and off my transistor and the transistor itself. And so the potential existed based on the size of the resistor I had on the LEDs for that pin to draw too much current from the CPU, which potentially, I mean, at a worst case, could damage the microcontroller, but the more likely case would be it would just end up resetting the micro repeatedly, and it just wouldn't work right. So as I was kind of passing back, diagrams and circuits and things like that, Gus chimed in and said, you might want to think about putting a resistor here. Like, oh, okay, that's a great idea. Let's do that. So
it's great to have, and Gus and folks are especially helpful there. It's great to have communities that will understand that this is a hobby. Like if you go to some dedicated boards full of people that work day in and day out, and you just like ask a noob question on there, they're going to just slam you and shut you down. But there are lot of hobbyist-oriented boards out there, especially with Arduino being so popular. I mean, tons of people are creating their own little boards for interfacing with Arduino. Same thing with .NET Micro Framework and Gadgeteer.
Yep.
Cool.
Yep.
All right,
Very
Andrew.
Cool.
So we have some other shows lined up here as well.
We do.
There's one here that I think will build on what we talked about here today, as well as what we talked about last week, which is about synthesizer kits. And I'm hoping to get some guests on there for that. So kind of their schedule is going to dictate when we have that particular episode. But I'm hoping to have that one soon because synth kits are something that you and I both really like. And I think it's one of the nicest ways to try out, soldering and learning how PCBs are assembled and everything.
Yeah, absolutely. Cool. Very cool stuff.
All right, Andrews, before I cut you off this week, any closing words?
I would say just, go out and create. I mean, again, for hobbyists, we've talked about this in terms of, game development. We've talked about it in terms of creating electronic music. This is a really great time for anybody who wants to get creative, whether it's through hardware or software or whatever else. The possibilities are really sort of endless. So, if you think, I always wanted a board that would do X, go make it.
Great. All right. And so we'll be back next week, hopefully with better audio, but yeah, right, because that never works on the show. And then we'll see you next week. Bye.